Hey everyone, we're going to solve the equation sine squared theta equals 6 times the quantity of cosine theta plus 1 on the interval 0 to 2 pi. Before we get started, what I notice is that my cosine is linear and we have a quadratic term. So I can change this sine squared. I can write this sine squared of theta using my Pythagorean identity here as sine squared equals 1 minus cosine squared of theta. So to do that, I'm going to write this as 1, substitute 1 minus cosine squared of theta equals, and go ahead and distribute this, 6 cosine theta plus 6. Now I have my cosine quadratic in quadratic form. Let's move everything over to the right hand side. So I'm going to add cosine squared to both sides. So it's going to be cosine squared of theta. Then this is already on the right hand side. And subtract 1 from both sides. So you get plus 5 equals 0. Now that it's in quadratic form, we can factor this. So this is going to be cosine theta plus 5 times cosine theta plus 1 equals 0. For this piece, if cosine theta, solve for theta, subtract the 1, you get equals negative 1. So our negative 1 here for cosine is your x value, so theta equals pi. All right, for this piece, we have set this to 0. So you have cosine theta equals negative 5 when you subtract 5 from both sides. If I put that in fraction form, just recall that cosine of theta is adjacent over hypotenuse. Your hypotenuse cannot be smaller than your adjacent side. So this is an extraneous solution. It's not possible. So we have to disregard this one. This is impossible. So we only have one solution, and that is theta equals pi. And that's it. Thank you. Have a nice day. Bye-bye.